It's their first taste of freedom. Researchers are releasing several Przewalski horses into the wild. In the 1960s, these wild horses were near extinction in their native Mongolia.
Imagine releasing horses into a frozen desert so lifeless that locals had long given up on it. No grass, no water, winters reaching 40 degrees below zero. A place scientists called a death trap for any wild animal. Yet a small group of zoo-born horses not only survived, but triggered a mysterious transformation that stunned experts around the world. What if the key to healing a vast, dying landscape wasn't machines or tree planting, but the hooves of an ancient wild horse? This story uncovers how bringing back the last truly wild horse sparked a chain reaction that could rewrite how we fight desertification everywhere. The desert's deadly decline. By the mid-1980s, the Zhongar Basin in China was no longer just a challenging environment. It was a warning sign for an ecological collapse of unprecedented scale. What had once been a vibrant steppe, teeming with life, had been transformed into a lifeless wasteland that local ranchers refused to call land. The soil beneath their feet had hardened into what scientists later dubbed biological concrete, a crust so impermeable that rainwater no longer soaked in, but instead ran off and evaporated within hours. This change crippled the natural cycling of nutrients and halted seed germination, effectively putting the entire ecosystem into suspended animation. For thousands of years before, wild horses had roamed this region, their hooves breaking up the soil and shaping the landscape. But after these horses vanished completely by 1969, the area began to degrade at a shocking rate. Satellite images from 1982 revealed the Gobi Desert expanding at 70 kilometers per decade, gobbling up grasslands, farms, and villages. Roads and railways had to be relocated as sand buried them, and Beijing, more than 1,000 miles away, became increasingly vulnerable to massive dust storms. In March 1983 alone, a single storm dumped 43,000 tons of topsoil on the capital, causing a 300% spike in respiratory emergencies. China's attempts to stop the desert's advance had been exhaustive but largely futile. Launched in 1978, the Great Green Wall project aimed to plant a 4,500-kilometer barrier of trees along the northern frontier. Unfortunately, the trees required far more water than the desert could supply. Water tables dropped by as much as 12 meters in some areas, leaving the roots to dry out and the trees to die from the bottom up. Villages had to be moved when wells ran dry, and engineering solutions like straw grids and drought-resistant shrubs failed to hold the shifting sands. By 1985, the situation had become a full crisis. Agricultural productivity in Xinjiang province had fallen by 34%, and computer models warned that, at the current pace, Beijing itself would become borderline uninhabitable by 2050. Scientists and officials alike were desperate for a solution, but the losses had been so severe and repeated failures so stark that hope was fading. The land was literally disappearing, and with no clear path forward, uncertainty gripped the region. In the midst of this despair, a small group of Chinese ecologists was preparing to suggest an idea so radical it seemed almost like fantasy. Their proposal focused not on machinery, chemicals, or mass tree planting, but on bringing back an ancient wild animal that had once been an ecosystem engineer here for millennia. This move, once dismissed by many as reckless, held the key to reversing the desert's deadly decline, but only if these animals could survive the brutal conditions awaiting them. What happened next would not just rewrite this chapter of conservation, but challenge decades of assumptions about desertification and recovery. The problem wasn't just about soil or water, it was about restoring a living force that had vanished, and with it, the delicate balance of nature. The answer would come not from human-built machines, but from the natural behaviors of a species thought lost to the wild forever. Few could have predicted that the collapse of the Zhongar Basin was about to spark a breakthrough in ecological restoration. But first, the question remained: what species could survive where everything else had failed? The hope rested on a horse, but not just any horse. The Przewalski horse reintroduced. The Przewalski's horse is not your typical equine. Genetically distinct, it carries 66 chromosomes, compared to the 64 found in all domestic horses. It is the sole truly wild horse subspecies on Earth, never domesticated, never bred by humans, and a living relic of the Ice Age. These horses embody thousands of years of evolutionary history. Their stocky builds, short, stiff manes, and faint zebra-like leg stripes almost like a link to prehistoric times. By 1985, the Przewalski's horse was extinct in the wild, wiped out from regions like the Yungar Basin for nearly 2 decades. The global population had dwindled to around 900 individuals, all living in captivity. The entire species traced back to an extremely limited genetic pool, just 12 to 14 horses captured between 1899 and 1903 for European zoos. After World War II, their numbers plummeted further, with only 31 animals left, 9 of which could reproduce. The threat of extinction was real, and the species lived on as a fragile bottleneck in zoos around the world. Recognizing the critical state of the Yungar Basin and the species, Chinese officials embarked on a bold plan. Over 3 stages, the project would import horses from zoos in East Germany and the United States, acclimate them in a breeding center at Jimsar, gradually rewild them in large enclosures, and finally release them into the Kalamaili Nature Reserve, an expanse of 4,000 square kilometers of some of Asia's harshest landscapes. At the center of this effort was Yang Jianming, a determined ecologist who argued that reintroducing these horses would do more than just save a species. He believed they could actively rebuild the ecosystem. These horses wouldn't merely eat grass. They would engineer landscapes, reshape soil structures, and revive natural processes lost for decades. His vision sounded radical, but given the failure of all previous human efforts, it was a fresh hope for a dying land. The reintroduction was complicated by the fact that the horses about to be released had spent generations in captivity, fed and protected, lacking the survival skills honed by their ancestors. They had never experienced the brutal winters or barren deserts. Many doubted these zoo-born animals could survive, let alone restore an ecosystem that was essentially starting from scratch. The horses didn't know how to find water across frozen terrain or read the dangers in the wild, raising real questions about how deep survival instincts ran. Yet the horses carried more than just genetics. They held into them an ancestral memory encoded in their instincts and behaviors, even if dormant. They were the last link to a natural order that had been lost when the wild had been tamed by humans. If anyone could bring life back to the desert, it would have to be a species like this, one that evolved alongside the land and its rhythms for millennia. Among the first released was a young stallion named Hong, whose straight white blaze made him easy to spot. Hong would later become crucial to the unfolding story, leading his herd through challenges no one believed they could overcome. But before any of that could happen, the horses would have to face a first test that many predicted would be their undoing, the harshest winter the basin had seen in years. The fate of these horses would determine whether this bold experiment was genius or folly. Survival was not guaranteed, and the desert demanded more than just resilience. The Battle of the First Winter. The horses' first months in the wild were nothing short of brutal. Once fed hay from buckets and protected from the elements, they suddenly faced a frozen desert where temperatures fell as low as -42 degrees Fahrenheit. Snow buried the sparse grass under 3 feet of powder, and water sources froze solid under inches of ice. The natural challenges tested every instinct and survival skill the horses possessed or could recover. Adding to the hardship was a wave of botfly infestations. The larvae burrowed deep into the horses' stomachs, causing painful lesions that disrupted digestion at the exact moment when the animals needed every calorie to survive the cold. The entire herd faced this attack, making the battle against winter even more precarious. Though the team watching from afar was forbidden to intervene, except in a life-or-death emergency, they witnessed some horses struggle visibly, with frostbite disabling 7 individuals and 2 mares miscarrying. Many observers had written off the project, predicting the horses would perish in a harsh textbook failure. Curators and conservation journals were already drafting criticisms, convinced the zoo-raised horses had lost the culture of survival, those learned behaviors passed down mother to foal in the wild, and could not adapt to the inhospitable desert. Yet what happened on the frozen steppe confounded all expectations. The the horses began demonstrating instincts no one thought they retained. Stallions broke through ice with their hooves to reach water beneath, a behavior never seen in captivity. Mares formed protective circles around their foals during snowstorms, rotating to share body warmth and block the biting winds. They dug through deep snow with sweeping leg motions to uncover hidden grass, a foraging method unknown to domestic horses. Their senses seemed to awaken as they read the wind and sensed which slopes might be safest or snow-free. It was as if generations of zoo life had dimmed but not erased ancient codes written into their bones. The wild was calling them back, and the horses were remembering how to live again. This survival in itself was a remarkable victory in a landscape that had been declared biologically dead. By the spring of 1987, signs of change accelerated. Grass species, absent from the basin for 17 years, began sprouting in areas where the horses had grazed. These plants didn't just return, they thrived. Compensatory growth caused by grazing triggered dense, healthy vegetation overlooked by earlier ecologists. In fact, biomass in grazed patches increased by 43% compared to untouched areas, revealing that the horses were not just surviving, they were actively rejuvenating the desert. This powerful start was only the first step in a long journey. The horses had broken through nature's final defenses, proving that survival was possible and that a small herd might spark a complex rebirth. Yet the harsh desert winters would return, demanding repeated resilience and adaptation. The real transformation was only beginning. The secrets of how these horses could heal a broken land were waiting to be uncovered. From the horses' survival in the winter, the story unfolds into how their footprints in grazing kick-started the desert's slow but steady awakening. How horses wake the land. What made these horses more than survivors was their ability to actively reshape the environment. Their hooves acted like natural machinery, breaking through hardened, concrete-like soil crust. Each step exerted over 800 pounds per square inch of pressure, cracking the surface and creating channels for rainwater to seep in. Across the landscape, this produced thousands of tiny water-holding pockets that helped moisture stay in the ground instead of evaporating quickly. Unlike machines, horses don't move randomly. They naturally avoid fragile young plants and focus on bare or damaged areas, creating a patchwork pattern of grazing and recovery. GPS tracking showed they moved in wide-looping routes, intensively grazing one area before traveling miles away and returning later. This behavior formed a mosaic of habitats that supported insects, birds, and small mammals. Ecologists call this a disturbance mosaic, a mix of short grass, taller vegetation, and open soil. Each microhabitat supports different species, increasing biodiversity. This pattern isn't accidental. It's shaped by thousands of years of evolution. In effect, the horses were restoring a natural design for ecosystem stability. Their manure turned out to be just as important as their movement. Far from waste, dung acted as a seed dispersal system. Studies showed they carried viable seeds from over 20 plant species, and digestion actually boosted germination rates by up to 300%. Their stomach acid softened seed coats and helped break dormancy in long-sleeping plants. Each gram of dung contained up to 7.4 viable seedlings, far higher than cattle or sheep. And because the horses traveled around 15 kilometers a day, they spread seeds across vast distances. Every droppings pile became a self-fertilizing, pre-seeded growth kit that accelerated vegetation recovery. Together, their hooves, movement, and waste reshaped the desert in ways no human project had managed. They weren't just grazing animals, but living ecosystem engineers, restoring processes that had been lost for decades. Still, uncertainty remained. Could zoo-born horses maintain these wild behaviors long-term, or was this early recovery just a temporary surge? The answer would unfold in the years marked by expanding grass, spreading seeds, and increasingly stable ecosystems. These forces set the stage for a cascade of life to emerge from the desert's shadows. The ripple effect of recovery. When grass began returning to the Junger Basin, it triggered a chain reaction far beyond expectations. By year 3, researchers recorded 22 plant species reappearing in areas that had been barren for nearly 2 decades. The seeds had never truly disappeared. They had remained dormant, waiting for the right conditions created by hoofprints, grazing, and manure-enriched soil. The land wasn't dead, just paused. As vegetation returned, insects followed quickly. Surveys found 43 insect species reappearing, including dung beetles that arrived in massive numbers. By burying horse manure, they broke it down and accelerated nutrient cycling, further improving soil health and fertility. This insect revival drew birds such as larks, wheatears, and sandgrouse, attracted by new food sources and habitats. Soon after, small mammals like gerbils, pikas, and ground squirrels returned, adding more layers to the recovering food web. Step by step, the ecosystem began rebuilding itself. Predators followed next. Cameras captured foxes, steppe eagles, and even gray wolves returning to the area. Their presence signaled a functioning food chain once again, with natural balance and regulation reestablishing itself through predation and competition. These interactions strengthened the system's resilience and sped up recovery. What began with a small group of horses gradually turned into a self-sustaining ecosystem. The changes unfolded faster than expected, as if a long-lost environment was reassembling itself under new conditions. The horses were effectively acting as ecological catalysts, restoring process that had been missing for decades. By the 1990s, recovery had advanced enough that the herd was allowed to roam freely. In 2001, fences were removed from the Kalamaili Nature Reserve, giving the horses full freedom and marking a major test of natural self-regulation. Once unrestricted, their impact expanded further. Satellite images began showing green patches spreading outward across the landscape, while the water table stabilized and then started to rise. These changes suggested that a broken hydrological cycle had been reactivated beneath the soil. In the end, the return of the wild horses did more than restore plants and animals. It restarted an entire functioning landscape. Their presence showed how quickly nature can rebound when its original ecological drivers are restored. The secret behind their success would change how humanity viewed environmental restoration forever. A model for global restoration. The success of the Przewalski's horses in China's Jungar Basin didn't just help restore a damaged ecosystem. It reshaped global thinking on ecological recovery. From just 11 horses, the population grew to over 500 by 2023, managing nearly 27,000 hectares of land. Their ecological impact, valued at around $25 million annually, came from improved soil health, water retention, carbon storage, and increased biodiversity, reframing them as vital natural assets rather than just wildlife. This success inspired similar rewilding efforts across Central Asia. Mongolia's Hooves National Park has supported a growing population since 1992, reaching nearly 500 horses by 2023. Kazakhstan launched the Golden Steppe Project, reintroducing horses from European zoos into the Kostanay region. Russia has also studied China's results to guide its own initiatives. Across these efforts, one lesson stands out. Ecosystems recover best when guided by natural evolutionary processes rather than human engineering. Unlike traditional restoration projects, this approach relies on living animals instead of machines or infrastructure. The horses function as ecosystem engineers, reshaping the land through natural behavior. Their hooves break up compacted soil and improve water flow. Grazing helps maintain open grasslands that conserve more water than forests in arid regions, and their waste spreads seeds efficiently. This makes the method more sustainable and often more cost-effective than large-scale tree planting efforts. China's Great Green Wall, for example, was designed to combat desertification through massive afforestation, but in some areas it unintentionally worsened water shortages by overusing groundwater. In contrast, the horses helped restore natural hydrological cycles, improving water infiltration and stabilizing soil. This shift highlights a move from artificial intervention toward ecological collaboration. Looking ahead, China plans to expand Kalamaili Nature Reserve by 350 square kilometers and grow the herd to 2,500 by 2040. Projections suggest this could restore over 100,000 hectares of degraded land, capture significant amounts of carbon, and support hundreds of species. It presents a potential global model for using rewilding to fight desertification while improving both environmental and human outcome. Ultimately, the Przewalski's horses illustrate that ecosystems often heal most effectively when their original engineers are restored. Their behavior helps reactivate natural systems that human intervention disrupted. This challenges us to rethink conservation, not as control over nature, but as partnership with it. It also raises a broader question: whether other extinct or displaced ecosystem engineers, such as bison, wolves, or elephants, could play similar roles elsewhere. Instead of relying solely on expensive engineered solutions, restoring key species might unlock resilient systems already shaped by evolution. This astonishing story shows how a handful of wild horses brought back from the brink revived a desert once declared dead. Their footsteps didn't just save a species, they restored an entire ecosystem and challenged what we thought possible in conservation. If you found this story inspiring, please like and subscribe for more eye-opening journeys into the natural world. Your support helps us share stories that spark wonder and change.